Hello class, this is Ms. Meyer and we're going to go ahead and start Unit 4 Video 2 today. We're going to be solving quadratic functions by graphing. So your learning target is that you will be able to solve quadratic equations by graphing. And we looked at graphing on our last notes video. Okay, so let's go ahead and take a look at what happens when you solve a quadratic by graphing. Just to remember, our quadratic is ax squared plus bx plus c. And there is a few types of solutions that you can get when you graph a quadratic. Okay, your first option is that there can be one real solution. Okay, a solution is where the function crosses or touches the x-axis. So if you look at this case, it's only touching the x-axis once. So that means there's one real solution. Our next option is that there can be two real solutions. If I have a function that looks like this, once again, I'm looking at where it crosses the x-axis. That's what makes it a solution. There is 1, 2. So this one has two real solutions. Okay, and our third option is that there's no real solution. Okay, no real solution means it never touches the x-axis. Okay, so if it never touches, there is no real solution. So with quadratics, you can have 0 solutions, 1 solution, or 2 solutions. So we're going to look at solving some quadratics today by graphing. So we're going to do the same process as yesterday to get it graphed, and then we're going to estimate the zeros, which is also the solutions, where it touches that x-axis. Okay, so first thing let's do is our y-intercept. Remember, that's our c value, so it's our ordered pair 0, 8. The vertex. Well, in order to find the vertex, we find the axis of symmetry first. So our axis of symmetry is that x equals negative b over 2a. So in this case, my b is 6, so I have negative 6 over 2 times my a is 1. So I have negative 6 over 2, so x is equal to negative 3. So our axis of symmetry is x equals negative 3. Then remember, to find our vertex, we take that negative 3, plug it into our equation, and we'll see what we get out. So let's go ahead and we're going to have y is equal to negative 3 squared plus 6 times negative 3 plus 8. This gives me 9. 6 times negative 3 is negative 18 plus 8. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So we have the vertex is negative 3, negative 1. And lastly, the zeros. That comes when we graph it here. So let's go ahead and graph this. So we have x is equal to negative 3 as our axis of symmetry. Okay, and I'm going to label x equals negative 3. Then I go ahead, I'm going to plot the y-intercept, 0, 8. So sometimes they might not always fit on the graph, so just do your best. Then remember, since we're symmetric, if I'm at 0, 8, I'm also going to be 1. So away from our axis of symmetry, it's 1, 2, 3. So 1, 2, 3. So we got negative 6, 8. Then I go ahead and plot my vertex, negative 3, negative 1. And now I would go ahead and connect these and see . Okay, there's my graph. Okay, sorry about that. Okay, so here is my function graphed. Now we need to go ahead and estimate our zeros. Well, our zeros are along our x-axis, so we have an answer here and an answer here. So my two zeros are at x equals, looks like negative 4, and x equals negative 2. Notice this is a situation where we have two solutions, because we hit that x-axis twice. Okay, now some of you might be like, I'm not sure, how would you make sure those are the exact numbers? You can do this on your calculator. Okay, so on your calculator, what we're going to do is we're going to graph the function. The way you graph the function is you go to your y equals, okay, and we're going to plug in x squared plus 6x plus 8. Okay, once you have it all typed in, you're going to go ahead and hit graph, and the graph will show up. You should then be able to compare. Okay, is this graph the same looking as this? Roughly, they look the same. Now, in order to get your zeros, what you would do is you would go second, calc. Do you guys see how calc is listed above trace? So second, calc. And look at that. Your option number 2 is 0. So we're going to do a 0. And then it says left bound. Okay, if I am trying to find, oh, it's not going to let me write on it. If I am trying to find this ordered pair right here, to be to the left of it, I'd have to be over here. So I'm going to move it over. The way I move it over is by pushing on this arrow here. So I'm moving it all the way to the left. Okay. Is it flashing to the left of my point now? Yes. So I am left bound. I hit enter. Now I need to be to the right of my point. So I'm going to move to the right of that point. And I am now to the right of it, just a little bit. I can move a little more. Hit enter. And the last one is a guess. You can move it and try and guess what it is, or you can just hit enter. So it says my 0 is -4, 0. Do we have an answer -4? Yes. Let's go ahead and check the next one. So second, trace again, because we're going to the calc above here. So second, calc. Number 2 is a 0, or 0. Same process, left bound. So here we want to be the left of this point. Am I to the left? Yes, so I'm going to hit enter. Now I need to go ahead and be to the right of it, so I'm moving all the way to the right of that point. So my flash is to the right, so I can hit enter. And like I said, the guess, you can move it to be close, or you don't have to. You can just hit enter again. And look, -2, 0. So there is my other solution, so those are correct. All right, so that's how you can check it on your calculator, which makes life nice and easy. Okay, so let's go ahead and move on to example 2. We want to graph it and then find these zeros again. Well, this one, in order to graph, let's go ahead and get everything onto one side and put it in standard form. So I'm going to have -x squared plus 8x, and then in order to get this over there, I'd have to subtract 16 is equal to 0. So we're going to go ahead and solve this one. Let's start with our y-intercept. Our y-intercept is our c value, so it is going to be 0, -16. The vertex and the axis of symmetry, let's find those, okay? So axis of symmetry, we would do x equals our -b, so -8, over 2 times our a, so -1. So we have -8 over -2, which is a positive 4, so my axis of symmetry is x equals 4. Then in order to find the vertex, remember we plug in 4, so we have so we have -4 squared plus 8 times 4 minus 16. So I have -4 squared is 16. 8 times 4 is 32 minus 16. So -16 plus 32 minus 16, that's going to give me 0. So my vertex is the ordered pair 4, 0. So let's go ahead and plot what we know here. My axis of symmetry is at 4. Sorry, just ignore that little mark off to the side. So we have x equals 4. Now I have 0, -16. So I know I can't fit down here, but we're just going to do our very best. -16 way down here. So that means I'm going to 1, 2, 3, 4. 1, 2, 3, 4. Over here I'm going to have 1. And if I have my ordered pair 4, 0 right here. Clearly I'm going down. And now if I look at this one only has one solution, and it's right on my x-intercept, so I already know the 0. That was our vertex. So the answer for this one is our x is equal to 4. So our 0 is at 4. So this one you probably wouldn't need to graph to make sure you knew the correct answer. All right, we got it. One more we're going to check. Okay, we're going to graph -x squared plus 4x minus 1 and find the zeros for this one. So first thing, y-intercept is going to be 0, -1. Vertex, -b over 2a, so -4 over 2 times our a, -1. So I have -4 over -2, which will give me out 2. So my axis of symmetry is at x equals 2. So I'm going to plot that on here right away. Okay, then we're going to go ahead and find the vertex. So I take my axis of symmetry and plug it in. So we have -2 squared plus 4 times 2 minus 1. So 2 squared is 4, so I have -4 plus 8 minus 1. -4 plus 8 minus 1 gives us 3. So my vertex is 2, 3. So let's plot what we have. We have our y-intercept is 0, -1. So that means I'm also going to have 4, -1. and my vertex is 2, 3. If everybody can tell, I'm going to have two solutions in this case. So if I do my best to draw this, okay, we can see that there's a 0 here and a 0 here. Right now it's not looking like we really can tell what it is. Okay, so we can graph on our calculator, but if you ever get something like this, you can just write between, because we're not sure. Okay, our first one is in between 0 and 1. And our other answer is between 3 and 4. Now, if you have a graphing calculator, I would recommend graphing this one on your calculator and actually checking your answer and writing down the more exact answers. So let's go ahead and do it on a calculator again. Okay, so now this time, we're going to go back to our y equals. We have our function from before in here. We don't want it, so you go clear, and then we go ahead and type it in. So negative. Make sure whenever you're doing a negative, you use this button on your calculator below. So negative x squared plus 4x minus 1. Okay, we're going to go ahead and hit graph. Okay, once again, does it look similar to what I have here? Yes, it does. It's both opening down, kind of in the same areas on my graph. So let's go ahead and figure out what the 0 is. So remember, we go second trace because we're going to the calc above the button. The blue second gets us to calc. We're going to 0, number 2. If I want to figure out this point, I need to be to the left of it. Does it look like I'm to the left? Yes, so I'm going to hit enter. Now to be to the right of the point, go up, enter, and enter for our guess. So this one says 0.2679. So is 0.2679 in between 0 and 1? Yes, I'm also going to write that down. So if you did this one on your calculator, x is equal to 0.2, did I say 671? 0.2679. Okay, let's go ahead and check our other answer to see if it's in between 3 and 4. So once again, we'll go second trace. Number 2 is 0, or you can arrow down. So now I'm trying to figure out this point. To be the left bound, so I have to be over here. Okay, I'm to the left of it, so enter. Now to be to the right of this point, it's over here. So move to the right. You can also notice see how this little arrow is pointing to go to the right. So it gives you a little hint. And then guess. This one is 3.732. So my other answer is 3.732. Is that between 3 and 4? Yes, it is. So either one of those answers would work. If you don't have a calculator, you'd write this down. If you wanted to on your calculator to get the practice, actually figure it out, that sounds great. Okay, so if you have any questions on how to graph and find the zeros, please write them down, come and ask me. Otherwise, we're going to move on to do a few word problems. So, number 4, in 1999, Adrian Nicholas broke the world record for the longest human flight. He flew 10 miles from a drop point in 4 minutes and 55 seconds using an aerodynamic suit. Using the information from the diagram and ignoring air resistance, how long would he have been in the free fall had he not used the suit? Use the formula, h of t equals negative 16t squared plus h sub o, where the time t is in seconds and the initial height h sub o is in feet. Okay, so what we need to do is figure out, well, what is his initial height? Okay, so his initial height is 35,000. So our formula is really h of t is equal to negative 16t squared plus 35,000. Okay, and we want to know how long would it have been in free fall had he not used his suit. Okay, well, free fall is this from 35,000 to 500. Okay, so how long is he really free falling? Well, from 500 to 3,500, he's really free falling for 34,500. Okay, so this is the distance that's happening for. So what we want to know is, well, what's his height? Okay, well, from here to here, this is his ending height, 500. So we plug it in. 500 is his height. And so in order to solve this, I need to get everything to one side. So I would have 0 is equal to negative 16t squared plus I would subtract 500, so it's 34,500. So that's how you get the distance that you're actually free falling. And I wrote one extra 0 on here. Or no, I was missing a 0 up above. So it should be 34,500. That's 35,000. Okay, and in order to solve this one, we're going to go ahead and graph it, and we're going to figure out what our solution would be. So we're going to find those intercepts. So let's go ahead and graph this one and find the solution. So we go back to our y equals. We're going to clear it out. We'd have negative 16, and I know it's t, but we use x squared, plus 34,500. Okay, if you go ahead and hit graph on this one, chances are it's probably not going to show up. And the reason is because it's going as high as 34,500. Our window right now is only set up to 10. So let's go ahead and change our window. Okay, our window, we want to make sure our y's are going up to at least 34,500. So I'm just going to have it go up to 35,000. Okay. And our time, we could go ahead and try and see if this works. Okay, so here's the showing. So I changed my height. I'm going up to 35,000. And if I look, it's not showing a lot. This is only going out for 10 seconds. So I need to go ahead and change my window to go up further. Kind of a guessing game. I'm going to guess at least double that, so at least 20. Let's maybe even go 40. So if I try 40, see what it shows. Does it show enough? Can I see where I'm going to hit? Not yet. So just to make sure we go far enough, I'm going to try 60 this time. Looks like it should be enough. Okay, so if I try 60. All right, perfect. So here it is. We can see that this was our height of 34,500 for this situation, and here is where the free falling ends. So I want to figure out what this value is here. How long was he free falling? So the way we do it is second trace. We're going to find the 0, so number 2. So left bound. Am I to the left of this point? Yes, so enter. And I need to go to the right. So I need to arrow way over. Okay, can't see it. Chances are I'm to the right, so hit enter. And enter, and there it is. My x is 46.435. So that's my time. And my time is in seconds. So using my calculator, I got that time was equal to 46.435 46.435 seconds. Okay, that was using my calculator. Another way to solve this is, do you see how there's just a t squared, there's not an x? You could actually subtract 34,500 from both sides. So we would be left with negative 34,500 is equal to negative 16t squared. Then I would divide both sides by negative 16. What that gives you is positive 2,156.25 is equal to t squared. And now if I want to get t by itself, I would take the square root on both sides. And you would get t is equal to 46.435 seconds. Either way is perfectly fine, so just those are both options. You can either do it on your calculator or algebraically. Okay, one more word problem, and we'll probably just do this one algebraically. Okay. So, example 5. The highest bridge in the U.S. is the Royal Gorge Bridge in Colorado. The deck is 1,053 feet above the river. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take for the marble to reach the surface of the water, assuming there is no air resistance? Use the following formula, where time t is in seconds and h sub o is the initial height above the water in feet. Okay, so we have our deck, and what we need to remember is our deck is this piece right here. But the marble is 3 feet above that. So whatever our height is, whatever this height is, we need to go ahead and add the +3 to it. Okay, so our initial height, our h sub o, will actually be our 1,053 feet plus 3. So our initial height is really 1,056. Okay, so h sub t of t is equal to negative 16 t squared plus 1,056. In this case, we want to know, when will the marble reach the surface of the water? Okay, so if we're falling all the way down here until we hit the water, what is my height? My height is equal to 0. So my h of t is my height, so I set it equal to 0. This one, we can go ahead and solve algebraically. I'm going to minus 1,056 from both sides. I'm going to go ahead and divide both sides by negative 16. When I do that, I get 66. So I have 66 is equal to t squared. Now I'm going to take the square root on both sides. And just don't forget, when you take the square root, there's 2 answers, but are you going to really want to include the negative time? No. So t is equal to the square root of 66, which is approximately, to 3 decimal places, 8.124 seconds. Okay, so there is your answer algebraically. Could we have done this one on our calculator again? Yes. I do want to show you some little tricks. First thing is, we went and changed our window to be all crazy for this one. So if you want to get your window back to the original, you're going to go zoom, and then you're going to do standard, which is number 6. That's going to bring it back to from negative 10 to 10, negative 10 to 10. So let's go back to our standard window, number 6. And then let's go ahead and graph this function. So y equals clear it out, and we have negative 16x squared plus 1056. Okay. This one, once again, if I graph it, is it going to show up? A little bit. You can see it a little bit here. But you can see that the height's going to go to 1056. So I'm going to change my window. Remember, your height is your y, so I'm going to change my y to go all the way up to, let's do 1060 to make sure there's enough. And let's just try that. Let's try our max at 1060 and see if it works. So we're going all the way up. And is it going to show us go all the way down? Yes. And I want to find this point. So to do that, I go second trace. My 0 is number 2, so I go to 0. Want to get this point? I'm flashing up here, so I'm going to move it down a little bit so I can see it. Now, am I to the left right now of that point? Yes, so enter. And now I need to go to the right. And my pointer or clicker might disappear, and that's fine. This is telling me my location. If my y is negative, am I below this? Yes. So I'm to the right, and I hit enter and enter again. And it also gives me that x is 8.124. So there is my seconds on my calculator. And once again, to get your window back to normal, you go zoom. Number 6 is your standard, so 6, and it takes you back to the original. Okay. If you want to go back to your screen, just go second. See how the mode above mode is quit? So second quit. Takes you back to the home screen. All right, that's going to do it for section, Unit 4, Video 2. If you have any questions, please write them down. Please let me know if you need help with your calculator, because it's going to be important that you know how to use it. All right, have a great day, and I will see you later.